What if I told you that one graph can represent thousands, or even millions of numbers? And what if I told you there's a faster way to write those ranges without using inequality signs? In today's lesson, you'll learn how to graph compound inequalities. Read them from a number line. And write them using interval notation. By the end of this video, you'll be able to move between inequalities, graphs, and interval notation with confidence. Let's get started. In the last lesson, we learned how to graph simple inequalities on a number line. But what happens when an inequality has two conditions at the same time? That's what we'll learn today. By the end of this lesson, you'll be able to graph compound inequalities. Read compound inequalities from a graph. Understand interval notation. Work with infinity correctly. Let's begin with interval notation. What is interval notation? Interval notation is another way of writing a range of values. Instead of using inequality signs, we use round brackets, also called parentheses, when a number is not included, and square brackets, which many of you may already be familiar with, when a number is included. Let's look at a few examples. Example 1. X is greater than 2. This means X represents all numbers greater than 2, so 2 is not included. Since 2 is not included, we use a round bracket. So in interval notation, we write round bracket 2, infinity. Remember, whenever we use a round bracket, it means that value is not included. Also notice that infinity uses a round bracket. This is because infinity is not a number. It simply shows that the values continue without an end. Example 2. X is less than or equal to 5. This means X represents all numbers less than or equal to 5. Since 5 is included, we use a square bracket at 5. So in interval notation, we write round bracket at negative infinity, and square bracket at 5. Notice that we always use a round bracket with infinity. This is because infinity is not an exact number. It represents a value that continues without an end. Also notice that we write interval notation from the smaller value to the larger value. Now let's see how interval notation works with compound inequalities. A compound inequality combines two inequalities together. Example 1. -2 is less than x, and x is less than 4. To graph this inequality, we draw an open circle at -2 and an open circle at 4, then join them together. Now understand this carefully. If -2 is less than x, then x is greater than -2. So the values of x are all numbers greater than -2 but less than 4. Since neither endpoint is included, we use round brackets at both ends. So in interval notation, we write starting from the smaller value, which is -2, round bracket at -2, and round bracket at 4. Example 2. 1 is less than x, and x is less than or equal to 10. This means x is greater than 1 but less than or equal to 10. To graph this inequality, we draw an open circle at 1 and a closed circle at 10, then join them together. Since 1 is not included, we use a round bracket at 1. Since 10 is included, we use a square bracket at 10. So in interval notation, we write round bracket at 1, and square bracket at 10. Example 3. -3 is less than or equal to x, and x is less than or equal to 1. This means x is between -3 and 1, and both endpoints are included. And on the number line, we draw a closed circle at -3 and a closed circle at 1, then join them together. So in interval notation, we write square bracket at -3, and square bracket at 1. Reading inequality graphs. Now that we understand how to represent inequalities using interval notation, let's learn how to read inequality graphs and convert them into interval notation. Remember, An open circle means the number is not included. A closed circle means the number is included. Let's look at this example carefully. Suppose we have an open circle at 2 and a closed circle at 8, connected by a line. The open circle at 2 means 2 is not included. The closed circle at 8 means 8 is included. So x is greater than 2 but less than or equal to 8. This can be written as 2 is less than x, and x is less than or equal to 8. In interval notation, we write round bracket at 2, comma, and square bracket at 8. Let's look at another example. Suppose we have a closed circle at -2 and a closed circle at 4 connected by a line. Since both circles are closed, both endpoints are included. So x is greater than or equal to -2 and less than or equal to 4. This can be written as -2 is less than or equal to x, and x is less than or equal to 4. In interval notation, we write square bracket at -2, comma, and square bracket at 4. Once you understand the relationship between circles and brackets, converting between graphs. Inequalities. And interval notation becomes much easier. Compound inequalities joined by or. Some compound inequalities have two separate solution sets. For example, x is less than -2, or x is greater than 3. To graph this inequality, draw an open circle at -2 and point the arrow to the left. Draw an open circle at 3 and point the arrow to the right. Notice that the graph has two separate regions. One region contains all numbers less than -2. The other region contains all numbers greater than 3. In interval notation, we write round bracket at -infinity, comma, and round bracket at -2. Union. Round bracket at 3, comma, round bracket at +infinity. The union symbol means or. It tells us that both intervals belong to the solution set. Let's look at one final example. X is less than or equal to -1, or x is greater than or equal to 4. To graph this inequality, draw a closed circle at -1 and point the arrow to the left. Draw a closed circle at 4 and point the arrow to the right. For interval notation, the first interval is round bracket at -infinity, comma, square bracket at -1. Union. The second interval is square bracket at 4, comma, round bracket at +infinity. Notice once again that infinity always uses a round bracket. A common mistake students make is using a square bracket with infinity. That is incorrect. Infinity is not a number. It represents an endless continuation. That is why we always use round brackets with infinity. Today you've learned how to graph compound inequalities. Read compound inequalities from a number line. Understand open and closed circles. Use interval notation correctly. Work with infinity correctly. And represent both and or. Compound inequalities. That's a big upgrade from just solving inequalities. If you can move between inequalities, graphs, and interval notation, you're already thinking like a mathematician. In our next lesson, we'll learn how to solve inequalities algebraically and represent the solutions on a number line and in interval notation. You don't want to miss that one. If this lesson helped you, give it a thumbs up, subscribe to Maths Masterclass, and share this video with someone who is learning algebra. Thanks for watching, and I'll see you in the next class.